worked in Java and Scala for like a dozen years, very statically typed languages. And then I switched to Clojure, my first professional dynamically typed language. And well, you know, I avoided learning Clojure earlier because I was afraid it would make me hate Scala, but I needn't have feared. So the lack of types really bugged me. I couldn't like tell what was where and what was going in and out until I found this library, Prismatic Schema. Prismatic is a company. It publishes a library named Schema, which is really a contracts library, but it kind of looks like types. And once I started using that, I found, oh, Clojure's all right now. I can see what's going in and out. I can at least document it and find out what's going in. And suddenly it got a lot better. And in fact, I think that this kind of contracts just might be the answer to the age-old debate between types and tests. These are two ways that we as programmers endeavor to answer the root questions of science and philosophy. What do we know and how do we know it? That's actually not a joke, but it's true. So what do we want to know is whether our code works. And how do we know it? Well, we might use types. We definitely use tests, or we might use just a lot of tests. The types approach this from a very mathematical perspective. It's a kind of formal proof. The compiler is guaranteeing that everywhere that calls this function passes the right kind of thing in, and that the function passes out what it says it does, and that every caller accepts that kind of thing. But as Dr. Corbett showed yesterday, while at some point, math gets hard. You add enough complexity and math gets really hard. It's awesome to have those guarantees, but when we can't calculate everything, we turn to science. Oh, you're supposed to be up there already. All right. Tests are more like experiments. If you run your computer, or if you run your program on your own computer and it works, and you're like, oh, works in my box, push it to production. No, that's anecdotes. Tests are more like evidence. We've run repeated experiments, and it's worked every time before. Therefore, we think our hypothesis is pretty good, and it's probably going to keep working. And that's great. With tests, you can test more than with types. And another great thing about tests is you can introduce them gradually. You don't have to prove to the compiler every single place you call your function that you're passing the right type. Sometimes in Scala, that can be a pain in the butt. Tests, on the other hand, you write as you need them. You can write them before you code if you want. You can add them later. You can run them when you choose to. And this is significant because not all code is of equal value. Most of the code that I type never makes it into production. Maybe I change it again in a few minutes. Maybe it never makes it off my machine. Maybe that feature is deprioritized and never gets merged into master. Or even if it gets into production, maybe nobody uses that feature. The code in production that's like being used all the time is much higher value than what I'm typing right now. So I like being able to introduce tests gradually as I have evidence that this code matters. However, there's something that types provide that tests don't, and that is documentation in exactly the right place. There's research that's been reproduced several times that shows that between static and dynamic languages, if the programmer is at least mildly experienced, like made it through a computer science program, they're more productive in statically typed languages. It's not a big effect, but it's noticeable. And the biggest reason for that, the biggest feature of the statically typed languages that helps is the types in function declarations, the parameters and the return values. People don't read the docstring even when it's one line up. They certainly don't go to another file and look at the tests. They look at the function declaration and then they use it. So people are more likely to use the functions right when the types are there. This is an example of how the types are supporting informal reasoning. Because math is awesome and science is great, but what scales as far as like our time expenditure is informal reasoning. It's our uniquely human talent that we don't really have to have proof to be sure about something. And in the end, I mean, this doesn't cross process boundaries. This can, but only with extreme work. At some point, you say, how do I know this works? Well, I call this library, and the documentation says blah, blah, blah. Or I know how the compiler works and how the computer works underneath, and and these are the cases I need to cover. This informal reasoning is what we use most of the time. I think it works this way. And so anything we can do in our tests and types to support that is going to make us more productive. So if we look at how contracts then can support what do we know and how do we know it, I'll start with what this looks like in Scala. So here's a nice function. It formats some report, right? It takes some data and turns it into something I can put in Excel. And I can see very clearly what goes in and what goes out. The shapes of those types are very clear. I can dig into them. I can dig around. In Clojure, on the other hand, the idiomatic thing to do is just pass hash maps of data around. And hash maps of vectors of stuff, which is awesome for the person programming it who doesn't have the overhead of like declaring types and stuff. But when I come back to it, it's not so pretty. The types in Scala provide like a skeleton for the program. You almost have to write the program in 2 layers, which is awesome when I'm doing type-driven development, which I frequently want to do, but not always. So with types, you define the skeleton, and the compiler guarantees that the hip bone connects to the thigh bone, and it all hangs together. And then you can flesh it out with the values and test those. But I don't always want to write my programs like that. Sometimes I kind of want to explore the solution space, and I don't know exactly what data I want to pass, or I want to build up my data gradually, bit by bit. And Clojure is awesome for this because you don't have to declare your type somewhere else. I mean, if you want to put more data in it, you do, and then you get it out and do what you need to do, and nothing in between has to worry about that. It's fast for exploration. But that gets painful when I come back to this function, and I didn't write it, or maybe me 2 months ago wrote it, which might as well have been a different person. And I need to change something. I need to twiddle the output based on something in the input, and I know that parameter that I'm looking for is in that report data somewhere, but I don't know where. So the Clojure way to deal with that is to stick a println in there and run it in the REPL, but that's not evidence. That's just, this one time on my box, I ran it and it was here. Therefore, it's probably going to be there. No, I want to know where it is all the time. So in real life, when I hit that problem, I had to go back to the code that populates that report data that comes in and dig and dig and dig until I found what I needed. And then I made the change and I pushed it to production. And it worked okay, but all of that, and it was like more than a day, that I spent satisfying myself with what was going to be in there all the time, was gone. It was just gone until I learned about this schema library. And now it's okay because when I come back to valuable code, it's valuable, it's running in production, and I spent this time figuring it out, I can document that, I can put it in there, I can test it with my tests, and I can leave it there for my future self to come back to this function and be able to figure out what's going in. So in this example, I'm going to show how I can gradually build a schema up, exactly where it's useful, and a couple of really cool things about Clojure that I like. So if we look at where format report is called, we have to do that in order to figure out what's passed in. A little bit of Clojure syntax, defin, here comes a function, here's a function name, here's a vector of parameters, and then the function body. This isn't what the code looked like when I got to it because it was much uglier than this, but this is what I like to refactor code in Clojure too. It's a little pipeline. The pointy thing up there, the skinny rocket, is called the threading macro, or the thread first, which is a stupid name because it has nothing to do with threads in the process sense. It's more like embroidery thread. What it does is it evaluates the first expression, so it's going to fetch the events based on the parameters, and then it takes the result of that and weaves it, embroiders it in as the first argument to the next expression. So it calls analyze add performance with events and params, and then it takes the result of that and uses it as the first argument and calls format report. I love this because it's a little pipeline of building up the data and transforming it. It looks kind of like this. I use the water wheel to represent the side effect of going to the database. So it's a total data transformation pipeline, which is lovely. And Clojure is very conducive to this because in Scala, I would have to declare every intermediate type, and that can get annoying and restrictive. So I wind up doing it, just programming in a different style. But I really like this style in Clojure. So for now, what I need to do, I need that blue jelly bean. I need to know what's in there. Fortunately, I can figure out what's in the rectangle because that's returned by fetch events, which is calling out to a relational database, and it's really easy to use my informal reasoning to figure out what's going to come back from a SQL statement. So I'll go to fetch events, and I look at the SQL, and it turns out it's returning stuff like this, a little map of what, when, and who. And now I can make a schema to describe that structure, and then I can verify it and make sure I'm right. So one cool thing about schemas is that they have the same structure as data. So in Clojure, data is data, code is data, and look, types are data. So a schema for that would look like this. I'm just defining a piece of data called event, and it has the same 3 keys, but instead of values, it has the types of the values, which in this case is literally their types, because a Java class is a schema in the sense that the schema library interprets it as anything that is an instance of this class. But I wouldn't write it just like this. I would bring in the schema.core library, and then I have an alias for strings, and I'd import the date time class so it looks a little nicer. I wouldn't write it like this either. I would choose to give names to these things because the what and the who are really different types. So I want to give those types names and be clear that those are distinct, but then I'm lazy, so I'll just define them as strings. Even though incident is probably like only who, or like show, click, and purchase, I could totally model that in schema, but I don't have to. I'm just like, yeah, well, it's a string, but I want to give it a name, yay me. So I can do that. And then I need a sequence of those to describe the output of fetch events. So I put the Clojure vector syntax around it, and poof, that represents a sequence of 0 or more events, where event is defined by that structure. I can go and add that to my fetch events function, bring in schema, and I change the defin to use the macro that's embedded in schema so that I get this extra syntax of the bird face operator. And that lets me declare that this function returns something of the shape of sequence of events. Great. So I can put that in production, and nothing will happen. Because in production, typically, you don't even compile the checks in there. So there's no performance impact at all. But in tests, that's where I want to get errors if I'm wrong. That's where I want to perform my experiments and get some evidence. So I go and I run this test, and if I'm wrong, nothing happens. Because even with the checks compiled in, by default, they're turned off. So I've got to tell Clojure Test to turn them off. You can turn them on for individual functions, and sometimes we would do that at work at like the API level if we really did want an exception if the schema didn't match. But usually, I just turn them on in tests like this, and this turns them on for the file. And now, if I was wrong and I run this test, I will get an error back when fetch event tries to return something of a different structure. And this is awesome because in production, if by some chance I actually get like extra data back, it won't care. It won't even check it. Good. So now I've got that. I know these are events. I want that jelly bean. So now I can dig into analyze add performance. And I find another one of these little pipelines. In my dreams, like actual well-factored code. Anyway, but when I find this, or achieve this, I can see that I've got a pipeline from these events to the jelly bean, and I can go through the methods and build it up. I know what events are. I'm going to group them up by customer, maybe, and then I'm going to have a sequence of sequences of events. It just grows. And then I want to make this little, attach a little summary to each of those groups. So in Clojure, this would be a sequence of tuples. No, I'm sorry, in Scala, this would be a sequence of tuples, which I could declare the types of each. But in Clojure, we would just use another sequence, a pair that happens to be a sequence of length 2. In Scala, one of the things that's a pain in the butt is trying to type heterogeneous lists. There's a shapeless library that does that, but that's a painful dependency to bring in, and it's a little scary. And in Scala, you'd use a tuple, but then you can't add new things to it. Here, I can add a summation. Okay, now I'm trying to declare, actually, that I have one sequence of events followed by one summation thinger. And I can define that elsewhere. And what's more, I can define summation to whatever level I want. I can just say, any. I gave it a name. That's what matters. And unfortunately, it's a little more complicated. I have to give it a name, which annoys me. But this way, I can have a heterogeneous list. I can add data to one of these lists if I want to add extra information to it. And I could just concatenate another schema onto this list and expand the type in the same way that I can expand the data, which is pretty cool. All right, but I want to group this in with more stuff. So we'll have a sequence of these, and we'll call it groups, and we'll put it in a map. And yeah, then there's some totals, which I can define as just anything or as a map of anything or to whatever granularity I want. Oh, we're going to stick some headers on it, and that's the jelly bean. Now I have some sort of structure defined to whatever level I need, and I can add detail as I want. All right, so I put the jelly bean on analyze add performance. I can also declare with some more bird faces the parameter types in there. And you can declare some of the parameter types or all of them or whatever you want schema to check. Another interesting bit is that because I can manipulate these things as data, I can write little functions to do that. So what if I want to say that I know there's this stuff in the report data and there could be some other stuff and I'm fine with that? So I would like to say that this method returns at least this report data map. And then I can just go make that function and I can say, okay, well that means take your map schema and add the any key to any value, which says and anything else. And then poof, I've got tiny little functions that manipulate my types, and I don't have to learn like a separate type language like Scala. Okay, so then we go to the tests, and I go to say this test. One of the things I love about Clojure is that when you want to test something, you rarely have to provide like more information than is relevant to your test, because you don't have to instantiate an object of the proper type and fill in all the constructor parameters with a bunch of stuff that, yeah, it gets messy. Here, I'm like, okay, this is about grouping of rows. The parameters don't matter in this case. I'm just going to pass the empty map. And this is wonderful while I'm exploring and while I'm building my unit tests and building my code up based on that. But now it fails. I bring in the validate schema, and it's like, oh no, that empty map is not a valid params object, because apparently I have filled in the schema for that. And the error message doesn't look nearly this nice, by the way. Clojure. So it turns out that when I make a schema, I find it is polite to also make a generator. So welcome to test.check. It's a library built into Clojure that does generative testing, also called property-based testing. One of the things it provides is tools to build up little generators. A generator is an object that can spit out random samples of something, whatever, in this case, a valid params map. The generators, in fact, if your schemas are nice and simple, you could use the schema gen library from Zishan to create the generators for you for extra easiness. Now, personally, here's a generator. It's spitting some out, and it'll spit out another one, and they're all random. The idea being that the generator like strictly defines what is valid input. I like to make my own rather than have them generate, so I can be a little more specific about exactly what is valid input. But it doesn't matter. I make this generator, and I put it in the test, and now it works. But what I like about this is that it's more expressive, because what I was trying to say with that empty map before was that the parameters don't matter. But it didn't actually say that. It actually said it does this with the empty map of parameters. Now it says the parameters don't matter. It says for any valid parameter. So that works. But you know, while I've got these generators, I might as well make a generative test. So the hard thing about this kind of testing is you make the generators, that's fine, and then they generate a bunch of valid input, and then you run it through your function, and then you've got to figure out how to test the output of your function when you didn't know the input data while you were writing the tests without duplicating your code. That's really hard. Except I'm not even noticing the output value. I'm not doing any validations. All I'm doing is running the functions because the assertions are embedded in the code. So that just takes away the hard part of generative testing while making it immensely more useful. Because now this is my compiler. This is my evidence gatherer that the types I have annotated my code with are correct. So what do we know? Schemas. How do we know it? Generative tests! This makes me happy, but obviously. But to get a little more detailed, what we can know right now, what we can specify in schemas, we can say what is the shape of the data. We saw that. We can say what are the boundaries of the values, because of course this is happening at runtime. I can check anything I want about the data, not just its shape. So for instance, I could say that the headers have a title, which is a string, and it's not empty, and it starts with a capital letter, sure. And I can do that because I can encode arbitrary predicates. I like how the both method doesn't just work with two. That's very Clojure-y. It works with as many as you want. Right, so I can put these value checks right in the types. I find that very clear. We can also specify relationships within a value. So in that same headers, if I've got, where'd it go? Yeah. If I've got the title and the start and the end date, I can say it's this map with this structure. Oh, and the start date is before the end date. All kinds of things. But I think we could take this farther. And I know we could take this farther because I coded some of this as a proof of concept, much of it on the way here. And there's more that we could know because there's stuff that the Scala type system lets me do that this doesn't. But we could get there. We could totally extend it. So like produce types, inner types, type parameters. I would love to be able to say, this is a generator of type param, and it always produces params. And if it ever doesn't, please throw me an exception and point me back to this line. I can do that, or I did that with a little macro. And this will basically take this generator over here and wrap it and functor map it across the validation check. So if it ever produces something invalid, I will know the problems in the generator. The other thing I use schema for is to narrow down bugs. Here's another one. This sequence of events is actually a problem. This bit us in production because the tests were behaving differently than the production system because the tests were validating the schemas, and to validate that schema sequence of events, it has to realize the entire sequence. What I want is to be able to declare that that's a lazy sequence. I don't want my validation to change the behavior of the code by realizing a lazy sequence earlier than it would otherwise be realized. So I added the colon plus operator to be better than the bird face. And I called it schematron. And now this will produce a function that wraps its output in something that maps across the lazy sequence and checks the events as they're coming out. And then if it fails, I could make it point back to this line. So that say, here you said this would produce these, but no. Similarly with functions, actually this is even more annoying because the function schema, this is the official one, if I pass a function into there, it'll look at it and it'll be like, it's a function. It can't actually check the types. And when you're doing higher order programming, that's really painful. I don't do as many like functions of functions in Clojure because it hurts. But there's nothing stopping me, and so I implemented this little macro. It's just a proof of concept. Let's see if I can find it useful, and if so, I'll make it better. But this one instead wraps the function in so that as it's called, the parameters are checked, and as it returns, that gets checked. So if I lie, if I pass in something wrong, I'll get back to this line, and I'll be able to trace who sent me a function that wasn't cromulent. So produce types are one thing. I would love to be able to say relationships between types. So for instance, I want to say that the sample1 method produces whatever type the generator outputs. So if it outputs params, if I get that. If I pass in a generator of ponies, I get a pony. And I can do that too. I mean, I could do it in straight Clojure with like just a function of a function. So you always have to call it with the schema, and then you can call it with the param or with the generator. I can also make a macro that does that for me so that I don't have to change my existing code, because the beauty of this is it's totally drop-in. Everything in schema is totally drop-in. It's not pairing your function calls with your function with the calls that it makes. It's all runtime, and you never have any obligation to match it with something else. If I could do that, I could do this with headers and like manipulate the schema types as data, and that would be really awesome. And I'd also love to be able to specify the relationships between values, like input and return. I'd love to be able to say, okay, the output sequence is just as lazy as the input sequence. But if you passed in a fully realized sequence, it's okay to pass it out. And in fact, I can do this because this is straight Clojure. This is Clojure post conditions. And I did this, and it bit me because I was wrong, and I found that out in production because these conditions don't hook into the same turning off of the validations, and I really need that. But if we had all these things, I think that would be really sweet. I think it would allow me to have the best of the skeleton when I need it, when my code has proven itself worthy of skeleton forming. And also I'd have all my exploration because I can do all those little data pipelines and little tests where I don't have to produce anything that I don't want to. I don't have to declare my types. I only declare them when they're useful for documentation and for evidence. It's almost like growing an exoskeleton or maybe climbing into a coconut. So I think this is a lot of the best of both worlds. What I did, I used Clojure and Prismatic Schema and generative tests to do science, evidence. But you know, it doesn't have to be Clojure. I mean, lots of languages have contract libraries, and lots of languages have property-based testing libraries. So you could do science too. But if you take nothing else away from this, remember that the whole types versus tests question is really about how do we know what we know, and that the most important part of being able to say how we know what we know is to be able to extend that in informal reasoning that crosses technologies, that crosses processes, that crosses languages. Here's some examples on GitHub and some resources. Various other people have done cool things with schema extensions and similar things. And the research paper points to the research that says static typing is slightly better. Oh, thank you to PolyConf and to Ordina. I'm speaking there on Monday, and they paid the rest of my travel. So thank you very much. Questions? Oh, there's one. Thoughts on Core.typed. So Core.typed is another like add typing on top of Clojure. It's different from schema in that it is a compile time thing. There's like a type check phase in the building. And it's also different in that it needs to match things up. So it does a great job of like figuring out the types where it can, but you need to provide type declarations for your library. So that's awesome if you have the patience for that. The thing about this is I can drop it into production Clojure code without bothering anybody. And I can do it only in the spot that I need it. I don't have to match it up. So that's what I thought was particularly cool about schema compared to Core.typed. But Core.typed is very cool.
Do you see any risk that doing these contracts and especially extending it in this way, like get so complicated that you start to need to have types and tests for your types and tests?
Oh, that's a great question. Okay, so I totally make tests for my schemas, and I make tests for my generators. Usually my generator test does it match the schema, but I also make tests for my schemas if they're at all complicated, because yes, in fact, I've got an extension of this talk that didn't fit here that talks about once you start making these schemas, then you need to start providing them to the users of your service. And you also need to have tests verifying your schemas and your generators and your other testing tools so that those tests generate evidence that testing with these is good for is like evident, can be applied to, so that what you learn from testing with these can teach you things that apply to the production code. Yeah, so tests of tests of tests.
I have a question here.
Does your generative testing stuff use the schemas to know what to generate or to guess more interesting cases to generate?
I think the schema gen library will do that, or at least it produces generators that produce valid stuff for your schemas. But I do find it a weakness in test.check that they don't emphasize edge cases the way something like Scala check or quick check does. I think that's something that we could improve about test.check, and of course, we're free to write our own
Thanks.
generators for that. Sometimes I do.